And 15, we have an equation that looks like this. And we have the relation is x equals tangent pi over 4y. And they've indicated here from 0 to 1 is the shaded part. And we have a horizontal slice. Okay. But since we're perpendicular to the revolving line, because they want us to do it around the y-axis, okay, what is that still going to create? If we go perpendicular to the revolving line, it's still going to create a disk. It's not a washer because there's no hole in the middle of it. It goes right up to the whole region goes right up to the revolving line. So ultimately it would create a disk. And so in general, we're going to go from 0 to 1 this time because we're in the y direction. And our disk method is pi times the radius squared. The radius of the disk is going to be defined by that x value. And that x value is defined by the function, which is tangent pi over 4y. Thickness, of course, is dy. And once we do that, type it in and get our answer.
Are we doing this about the y-axis? in the equation 2 pi then, up front? Is that a cylindrical?
Remember, we're still using disks. It's not a cylindrical shell.
You have to square it.
Yes, you're right. Sorry. Got my square there. So that stuff all squared. And of course, when you type it in your calculator, these are going to be x's, not y's, but still the same idea. Okay. Questions on that setup? Justin?
I have a question. How do you know when it's going to be either just a normal, like, what do you call it, as a disk method, or if it's going to be the washer method?
I mean, ultimately, if you were to take this slice, isn't no matter where you draw the slice in the region, isn't it going to be buttoned up next to the revolving line? So then, could there be a hole in there possibly? Whereas if I had something like this, if I had this function, and let's say this function, something like that, then would my slice right there, would my slice have a hole right here?
Oh, yeah.
So basically, if the region is touching the revolving line, it's going to be a disk.
What are you using the cylindrical method?
And ultimately, even in this case, we'd still have a washer though, because it's perpendicular to the revolving line.
When do you use the cylindrical method?
Cylindrical shells is when the slice is parallel to the revolving line. Always get disks and washers when it's perpendicular. What else? Devin?
Still on 15.
Mhm.
The answer in the back of the book is 4 minus pi. When I either plugged something wrong in my calculator or I got
Ultimately, it doesn't say analytic. I mean, it doesn't say analytic method, so if your decimal compares with their decimal and it's the same, then you're good to go. Ultimately, unless it says analytic methods, you don't need to do it by hand here at this point. Yeah, I don't know, maybe it could be in the wrong mode too if it doesn't match up, but this would be the right setup. What else? Okay.
31.
31, we have the region that's enclosed by a triangle with vertices 1, 0, 2, 1, and 1, 1. So this is our region. And we're revolving it around the y-axis. True? So we really, in some cases, we could use either choice we wanted to. If we wanted to use a vertical slice, we could, or if we wanted to use a horizontal slice, we could. It's really kind of up to us. If you want to do it with a washer method, then I would use a vertical slice, or a horizontal slice, I should say, because it's going to be perpendicular to the revolving line, which again is the y-axis in this case. And so ultimately, if we do that, we're going to go from 1 to 2. That's where our, oops, I lied. We're going to go from 0 to 1. We're in y direction here. Okay. So again, we're going y direction because we have a horizontal slice. So we go from 0 to 1, and then the washer we create would be, the outside radius would be from here to here. So how far would it be from here to here? And keep in mind here, we're going to need an equation that's written in x in terms of y. So 4x in terms of y. We ultimately would we need an equation for that line right there? Because that part would depend on where we are on the interval, wouldn't it? Okay, so ultimately this equation right here goes from 0, 1, 0 to 2, 1. Obviously the slope is 1. Okay. If we go down 1 over 1 here, we'd have ultimately the equation of this line right here would be y equals x minus 1. And so therefore y plus 1 would equal x. So our outside radius would be that y plus 1. Then we're going to take the equation that is this line right here and solve it for x because we're dealing with y coordinates here. And then we're going to subtract the inside radius, and what's the inside radius, which is this right here? That's just 1, so 1 squared dy. And with that comes calculator problem. Okay. So if we plug that in there, we're good to go. So just for argument's sake, let's see what happens here if we try that. We do our math 9. Whoops. And we do our y plus 1 squared minus 1. Get 4/3. So ultimately it'd be 4 pi over 3 then would be our answer. Alright, and just like I said, for argument's sake here, let's do it the other way. Let's do it with a vertical slice instead. If we use the vertical slice, a vertical slice then would be parallel to the revolving line, and we create not washers, but shells. Okay. So our setup for that would be 2 pi. We'd go from 1 to 2 this time because we're in the x direction, so we're going from 1 to 2. Okay. And then our first parentheses, which is our distance from shell to revolving line. Okay, what would that be if I went from distance from shell to revolving line, if I wanted to find out how far it is from here to here? Yeah, ultimately that would just simply be x, wouldn't it? Because if I put it here, it would be where I have it drawn, it's like 1.5. If I drew it over here, it'd be 1 1/4, 1 3/4, whatever. It's just the x value in question, isn't it, in this case? So that would be x. And then the height of that shell would be 1 minus x minus 1. Because the x minus 1 is the bottom of that region. 1 is the top of the region. If I subtract those two, that'll give me that distance right there. So 1 minus x minus 1 will give me the height of that shell. And again, if we do our math 9 again, if we did everything correctly, we hope that we'll get the right answer here. So ultimately it would just be negative x. And nope, something's not right. What did I type in? So,
Type it in.
oh, it's plus, never mind. It's 2 minus x, sorry. Try that again. 2 minus x, because this is 1 minus negative 1. And we get that, which is not the same, but remember, what are we multiplying this by? Not pi, but 2 pi. So if we multiply by 2 pi, whoops. Get that, which, if I go, actually I don't even want to do the pi in there. If I just multiplied it by 2, I would have gotten 2/3. Right? No.
It's 2/3.
Yeah. So ultimately, try that again. So this right here would be my integrand, correct? So ultimately that would be 1/3. Still not.
It's 2/3.
Oh, 2/3. Well, 2/3. So the integral itself is 2/3 times 2 pi would be 4/3 pi. So 0.33 repeating would be 1/3. Thank you. So ultimately, if we go our 2/3 that we get from the integral times our 2 pi, we get 4 pi over 3. So bottom line here in this case, when we have a choice, which one's better? Neither. They're both the same. They're both just equally valid methods to use, so it really doesn't matter whether you use a vertical slice or a horizontal slice. As long as we have the same top and same bottom throughout the region, you could use a vertical slice. As long as we have the same left and same right throughout the region, you could use a horizontal slice. So it's up to you on which one you choose. What else?
35.
Okay, 35, the region that we have here is y equals radical x, and lines y equals 2 and x equals 0. So if we have y equals radical x, and line y equals 2 is going to be here, and x equals 0, of course, is the y-axis. So this being our region, we know that those would meet at 4, 2 here, of course, because square root of 4 is 2. So that would be the region in question. And we're asked to revolve this around several different things. First of all, the x-axis. So if we were to revolve this around the x-axis, and again, notice that we have the same top, same bottom throughout the region. We have the same right, same left throughout the region. So it's, again, totally up to us on what we set up. We could set up discs or washers, or we could set up shells. It's up to you. So just for variety's sake here, let's go ahead and do, a horizontal slice, which means for the x-axis, we would have a shell, if you will. So if I have it parallel here, from part A we're going x-axis, and we'll do a horizontal slice. That means it's parallel. So that means we're going to get a shell here. So that means from 0 to 2 would be our limits, 2 pi. And then how about our distance from shell to revolving line? Would be that right there. And what is that distance right there? This right there would be, remember, keep in mind we need to have this in y. This is just simply y, isn't it? Wherever I would have drawn that slice is just a y value. That distance is whatever y value we're at. So we have y. In a lot of shell problems, the general formula here is going to be x f of x, or y f of y. Okay? And that would only change if the revolving line is ultimately not next to the region, if you will. Okay? So it's not surprising that it's y or x like it hasn't been in the last two. And then the other part here is the height of the shell. Okay? The height of the shell is this distance right here, which now depends on the function. Okay? And remember the function here is y equals radical x, so that means y squared would equal x if we change it to a y version. And so therefore y squared would be our shell height. And if we go that with dy, we will have our setup correct. And from there it's just a calculator problem. Questions on that one? Now, if we were to take that same region and go around the y-axis, since we already have the picture drawn with the horizontal slice, let's do the horizontal slice with the y-axis. So remember with the y-axis, we would have a what? If I revolve that slice around the y-axis, that would be perpendicular to the revolving line, so therefore we generate discs. Okay. Here's an example again of, there's no hole there, so it would be, they'd be right next to each other, so it would be a disc. So for part B, we could go 0 to 4 this time of pi times, and what's the radius of that disk? The radius of that disk is just simply radical x dx. Nope, I lied. Still y squared, sorry. And we still got 0 to 2. Okay, we're in a vertical slice now, so scratch that. So we're going, integrand here would be y squared dy. So we're going 0 to 2 because, again, we're still dealing with a horizontal slice. So no matter whether it's discs or washers, if the slice is horizontal, we're dealing with y's. Okay, so not only on the limits, but also on the integrand and our dy. So therefore, that would be our answer for part B. And then on part C, we want the line y equals 2. So I'm going to do my redraw here. So if we're going to do it around the line y equals 2, which is right here, and again, totally our choice as to which kind of slice we use. It's up to us. So if we want to use, just for switch up sake from the first time, let's say we want to use a vertical slice in doing this one. So our vertical slice would be perpendicular to the revolving line. So that means we would be dealing with discs, because again our shape would look something like this if we did it in 3 dimensions. So our slice would be a disc. And so therefore we'd go, if it's again vertical, that means we're dealing with x. So we go from 0 to 4. We go pi, and this is where now we'd use our radical x dx. However, this right here would not be right because this would be the answer if we were revolving around the x-axis, or this, or some variation. Bottom line here is we need to know what is the radius of this disk. What is that right there? That distance right there is not radical x, it's what? It's 2 minus radical x, isn't it? Okay, remember, from here to here is radical x. From here to here, well, from the whole thing is 2. So what's this leftover part right here that we want? That's 2 minus radical x. So it's not radical x as our integrand, it's 2 minus radical x. So again, the expression we put here needs to be the radius of the disk. And the radius of the disk is essentially that slice right there.
That's all squared.
Okay? And that would be squared, and then we're good to go because it's always going to be the form pi r squared dx. Okay. Alright, so that would be our correct integrand for that one. And then ultimately, if we do x equals 4 line, so we're revolving around that line right there. Again, we can do a vertical slice or a horizontal slice. It's totally up to us. Let's stick with a vertical slice this time since we did the first two with the horizontals. So our integrand here is going to be 0 to 4 since we're dealing with x because we have a vertical slice. And then ultimately what is that going to create if we have this slice and this revolving line? They're what to each other? They're parallel to each other. So if they're parallel to each other, we're going to get shells. So therefore we're going to need 2 pi here. We're going to need in this first parentheses the distance between the shell and the revolving line, which is this. So the question is, how far are the shell and the revolving line apart from each other? Well, what is this distance here? This little distance right here would be x. So this distance would be 4 minus x. So our first part of our integrand would be 4 minus x. And then what about the height of the shell here? How tall is this shell here? That's 2 minus radical x, isn't it? 2 minus the function. And then from there again, it's a calculator problem. Questions on that setup? And again, if you have time on a quiz or test or on the AP test, if you have extra time, and you had one like this that could be done with verticals or horizontals, could you do them with both and make sure they agree? Kind of like what we did in that last problem? Sure, you got time. I wouldn't suggest doing that right off the bat, though. So if you got extra time, though, as opposed to turning it in early. Go back and try it again the other way. Make sure they both agree. If not, then maybe there's a mistake somewhere. What else?
41.
41, we got the same function y equals radical x. And we got y equals 0 and x equals 4. So y equals 0 is the x-axis. X equals 4 is this vertical line. So instead of doing the top half of that, we're actually using this as our region now. Remember our boundary, the boundary line is not the top, it's the bottom this time. And we're going to use the shell method to revolve that around the y-axis. So around the y-axis, we're going to use the shell method. They want us to use a parallel slice then. So we're going to set up a shell method. So we're going to go 0 to 4, 2 pi. And this time, what's the distance between the shell and the revolving line? How far is it from here to here? It's just x. And then our height here is radical x. And that would do it, wouldn't it? Questions on that setup? What else? Mike? 27, we got says the region in the first quadrant that is bounded above by the line y equals radical 2, below by secant tangent, left by the y-axis, and we're going to do that about the line y equals radical 2. So ultimately, we need to see this line y equals radical 2. Of course, we know what that looks like here. If this is our 2, then our y equals radical 2 is going to be this horizontal line. And we know that the y-axis is a boundary also, so keep in mind that's a boundary. And then if we draw a picture of secant tangent, let's see what that looks like. So and our window here, we're going to go from 0 to probably doesn't go past the asymptote, I'm going to guess. So here, so we got pi over 2 would be the asymptote. All right. So secant tangent looks something like that. And eventually it's going to hit that line, of course, so base our general shape is this. Right? So if we're going to revolve that shape around the line y equals radical 2, this being our revolving line, I would suggest that a vertical slice is kind of our only option here, because we want to try to have to solve that thing for x and get y alone, get it in terms of y. not y equals secant x tangent x. That's going to be pretty difficult to get x alone in that equation, right? So really our only choice here is to use a vertical slice, which is it's a vertical slice and a horizontal revolving line that makes a disk again. Because again, the top of this, in 3 dimensions is going to eventually look something like that. So if we revolve this slice around that line, and our setup here is going to be in x, and we know it's a disk, so it's going to be pi. We know that it's going to go from 0 to something, and ultimately that something we know is pi over 4. We did that in the last problem. Remember, our pi over 4 radical 2 is going to be our intersection point there. If we want to, just to make sure, if we weren't sure about that, we could actually, if we just did tangent pi over 4, oops, not 14, times 1 divided by cosine pi over 4, we get 1.41, that's radical 2. So you can verify that intersection point. You could also graph radical 2 and then do the intersection command. You can see that it is 1.4 blah blah blah, which is radical 2.
Should we know that? Like, what are we just gonna guess?
Like I said, if you didn't know it, you could find it by doing that. Okay. And ultimately, if you use all these decimal places in your, and you ultimately just need to make sure you figure out what the right x is here. So if you knew the y value, which we do, and you found the x value, you could use that decimal approximation for that. I mean, if it's 0.78 blah blah blah, you might recognize it as pi over 4. But either way, if you use all the decimal places your calculator gives you, it's going to give you the right answer to the nearest thousandth anyway. So, all right, and so at this point, we need to figure out if we can figure out what is the radius of the disk. Well, what is that height right there of that disk? It'd be 2 minus secant x tangent x, all squared. Radical 2, not 2 minus. There you go. So radical 2 is the top of that function, or the top of that region, and the bottom is the secant x tangent x function. So ultimately it would be radical 2x minus secant x tangent x all squared dx. And again, from there, calculator problem. Keep in mind that these are calculator problems because it doesn't say analytically. We could certainly do some of these by hand because we could find antiderivatives and so on. But in the scheme of things, unless it says analytically at this point, we set up the integral and we do calculator. What else? Okay. 49, we have an equation here, y equals x over 12 times the square root of 36 minus x squared. And it says we're asked to design this plumb bob that will weigh in the neighborhood of 190 grams. So you decide the shape of it, to shape it like a solid of revolution shown here. And we want to find the plumb bob's volume. So ultimately, again, in 2 dimensions, the curve looks something like that. So if we want to find the volume that's going to be created, we could use a vertical slice here. And again, we want to use a vertical slice because we don't want to have to try to solve this for x, number 1. Okay? So we can go from 0 to 6, and we'd create what kind of shape with this? It would ultimately be a disk. Okay? So if we had a disk, it's going to be pi. The radius here is going to be the function itself, so x over 12, square root of 36 minus x squared, all squared dx. So if we find that volume, I'm going to go back up and put my parenthesis, put a parenthesis around that whole thing in order to have the whole thing squared. Comma x, comma 0, comma 6. 7.2 pi then would be our result. Questions on the first part? All right, and ultimately here in part B it says if you specify a brass that weighs 8.5 grams per cubic centimeter, how much will the plumb bob weigh to the nearest gram? So keep in mind that what we have here, what we've just calculated here is centimeters cubed. True? And they've also given us a measure of 8.5 grams per centimeter cubed. And ultimately, if we want to get a number of grams, then what are we going to do with these two numbers here? Think of the units. Wouldn't this unit times that unit give me just grams? So ultimately, our nearest gram will go 7.2 times pi times the 8.5. So how many grams? 192 grams then would be our weight. And remember, this thing said somewhere in the neighborhood of 190 grams, so how did we do? I guess it depends on your definition of somewhere in the neighborhood of, but ultimately that's pretty decent. Questions on that one? What else? And 16, we're going to take that sine cosine function and revolve it around the x-axis. So ultimately with that vertical slice that they've given us, what's that going to create if we go that around the x-axis? Yeah, it's a disk, so we'll go from 0 to something. We don't know that something quite yet here, but ultimately it's going to be pi times sine x cosine x squared. So the radius of the disk will be the function in this case. And ultimately we need to figure out what's that right there. So think about when would sine x cosine x equal 0? Well, it would equal 0 at 0. We know that because the sine x would equal 0. Cosine x would equal 0 when we're at pi over 2. So ultimately the integrand, the upper limit then would be pi over 2. And then from there, calculate a problem. How about from the binder questions? 63 through 68. I believe all the answers are on there, right?
65.
And 65. We got, it says the base of a solid in the region enclosed by the graph of y equals ln x. And the line x equals e. And the x-axis. So ultimately we have our ln x curve. We have the line x equals e, which is ultimately, that's 1, 2.7 something. So here we're at that point. So the region then would be this. We graph all those boundary lines. The x-axis, the line y equals e, or line x equals e, y equals ln x. And it says if the cross sections of this S are perpendicular to the x-axis are squares. So if we draw a slice in here, perpendicular to the x-axis, and we have a square coming out of the page at us. Something like that. And the question is, what is the volume of this particular solid? So, we know that in general, if it's a square shape, that we start out with our square formula. And from there, we've got to figure out, can we come up with an expression then for this S here, which is the side length of the square? Well, ultimately, isn't it just ln x? And so if we sum up all the squares, that becomes our integrand, that volume formula, in x. And then what about the limits here? We're going from 1, ln of 1 is 0, so we're going from 1. And then how about this point here? What is ln of e? So remember, we're trying to figure out ultimately what is the intersection point between, actually we're doing, no, I said that backwards. No, it's just e. So not ln of e, it's just e. So we're going e in this direction. Remember, this is the line y equals e. Okay. We don't really need to know what that intersection point is at all anyway, because we're not dealing with y's here. So we know the intersection point is e. It's given x equals e. So if we do from 1 to e of ln x squared dx, let's see what happens. Make sure when you put e in there, e is going to ask for an argument. Remember, it's e to the 1. 0.718 looks like letter A. That would be correct. Questions on that one? Alright, what else? Binder problems. Doug?
There can't be like any crazy curveballs like close forms,
No.
any specific, like, there's some special problem with that one be on there, you know what I'm saying?
Nope. Ryan? 66, we got, this time our region is in the first quadrant, bounded by the graph of 8 minus x to the 3 halves. So I would suggest drawing a picture of that, so we know what kind of equation we're dealing, know what kind of graph we're dealing with here. And first quadrant here, if I go, let's just say 0 to 5, 0 to 5. So it looks like that. If we go up a little higher, maybe it see an intercept up there, which we do. And it shouldn't have been, I guess, terribly surprising that it was 8 because it's 8 minus x something. So 0 and there we go is 8. So ultimately we have 8 here. And this turns out to be 4 because if we do 4 to the 2/3, we get, or 4 to the 3 halves, we get 8. So 8 and 4 are the two intercepts here. So that being our curve, and our task at this point is to says which of the following gives the best approximation for the volume of the solid generated by revolving this around the x-axis. So pretty good disk problem then, I would say, if we use a vertical slice. So if we go from 0 to 4, pi times 8 minus x to the 3 halves all squared dx. And if you punch that in your calculator, it should be 361.9, which is letter E. Questions on that one? Anything else? Okay.